Hello, welcome to this Unreal Engine tutorial. I'm the Festmaster. Today I will talk about how to properly structure a blueprint class. I've not seen a tutorial covering this information, so I thought I should make one. So here you go. I hope you learned something. To begin with, this is a first-person template, blank project. I'm going to open up the blueprint for the player character. And here it is. This is your blank blueprint made by Epic. So the first thing is we're in the event graph. This is the most common area people write code. It's not the best, but it is the most common. And in here, in this blueprint editor, you have all the different things. You have your component stack, and then you have the different graphs, as well as everything in them. Different functions, macros, variables, and event dispatchers, which are more used by component classes than actor classes. Let me just select something, and over here we have the details panel, which is where you'd be able to change settings for certain nodes, but more commonly change settings for components. So for this video, we're more interested in the different functions and ways of packaging your code rather than components. So we'll start with that. So the first type of packaged code you can make is a custom event. You can just make one like that, call it something like say hello. You can now call this at any point in your code. So instead of the regular default firing of a projectile, we can call say hello and call it. And then if off of this we did a print string that said hello and hit compile and play, when I click, it says hello. This is one of the easiest things to do. Custom events are pretty good for when you want to do a bunch of stuff that happens when like a certain condition is met, like the tick event or the begin play event, which is somewhere around here. Here it is. It's when you just want to do a bunch of things in an order and you don't care about getting any information back. It's not good at all if you want to get information back. It's very nice because it's a very easy fire and forget event. You can just call it and not have to worry about anything afterwards. There's also a further existence that since it exists within the event graph, you can use delays, if I can spell it right, and timelines, which are two powerful nodes in your blueprints. The timelines, which I'll probably make a tutorial entirely on them later, is very useful for like animated things like a moving or like a rising and lowering staircase, something that slides back and forth. Delays are very useful because they just pause the code from executing for a certain period of time. The only place these can be used is on the event graph. There is another type of delay called the retriggerable delay. The delay, once it receives an execution in, it'll ignore all the execution in until this time is passed, and then it will fire one out. The retriggerable delay, every time it gets a execution in, it resets its counter back to the max time before it sends, and then once that reaches 0, it'll send one out. So if you have one of these connected to tick and this is set to 1 second, you'll never end up getting anything out unless your frame rate drops below 1 frame a second. Like you have 1 frame every 2 seconds. That's the only way you'd be able to do that. While with this delay, and you hooked it up to tick and had it set to 1 second, you would get a pulse out every second. Because as soon as that pulse is sent out, another one has come in and started the delay all over again. That's the difference between the two different delay nodes. But anyway, back to events. They're pretty useful, but they should not be a catch-all. You definitely don't want to write all of your code in the event graph. I'll just put this back to the way it was, but in this blueprint, that's okay that it's all in the event graph because it's basically all events. So like you have what happens when you fire, it's just does a bunch of stuff. What happens when you jump, does a bunch of stuff. The second really useful thing is a function. So let's just create a new function. We'll call this trace line. And this is a function that I tend to make a lot. The functions will open up a new graph. The way I made the function is I just added a function and then typed in the name. So you have your event graph here, and then now we have a second graph for trace line. You may notice that there is another function that exists called the construction script. This is a default part of any actor. This is run both when it is created in the world and when it is edited in the editor. So like if there was a there is a construction script for this, and every time I move it, that construction script gets run. As you can see there, we can just attach a print string onto the end that says hello, and then when I come into the editor, you'll see that it prints hello every time I move this around. So that is, the construction script is a very good place to write smart actor code. Like if you want a setting that changes a setting in the actor, which is would be a variable that you make instance editable, which I'll talk about later. You could use that to make actors that have settings that you can change and it affects what they look like or how they behave. So in our function, we will just create a new variable, or not variable, new input, call it a float and call it distance. And so the idea behind this function that we're building as an example is to just trace a line straight forward from the camera and see what we hit. So we can do a line trace by channel and hook up the execution, and then find the first person camera, get the world transform of that camera, and then I'm just gonna, oh no, I don't want the world transform, I want the world location. Get world location of the camera, and also get the forward vector of that camera. We'll just multiply the forward vector by the float distance, and then plug this into start, and then add a vector to a vector, and add this on to the end, and then we can create a return node, plug this in, plug in the hit and the value. So the purpose of this function is to perform a line trace, but I don't want to have all of this in my event graph. I just want one function that I can plug in one variable, distance, instead of all of these things. And essentially I could also change what channel it is in here and what actors by default to ignore if there were other actors that I don't want it to ever hit, like ones that the player has picked up or something. Like you have a box that you can pick up, and then if you were performing this line trace, you would want it to possibly ignore that box by default. So any box that happens to be picked up, there would be a variable for it in the blueprint which would allow it to be ignored. So just setting up that basic functionality but having it very simple, so we can come into the event graph and call line trace function that we made, and just set the distance to something, and hold B, click for a branch, nice hotkey tip, and then if we have hit something, we can print a string, not hello, but break this hit result to get what we're hitting, the hit actor, get the object name of the hit actor, and print that so we know what we hit. When we come play, it's not printing anything because we're not passing that condition because you didn't hit anything, but as soon as we come up here, it prints the name of the object that we're hitting. So that's a quick example of the way you would use a regular function. Now there are a couple other things in here. One, you can actually change the default input value for one of your inputs. So maybe we just always want this to be default 500 so we don't have to manually put in 500 every time we drop down a line trace function. This is very useful. There's also pass by reference, which would be useful for, say, if this function was being called by an external actor and that actor had a value in it that needed to be modified by this function, there would be two ways to do that. One, you could modify the value and then return the modified value, and then in wherever you call the function, reset the original value to the modified one that's being returned by the function. Or you could pass it by reference with this checkbox, which changes the pin to a diamond reference pin, and also removes the default value because you no longer have a default value because you have to have a variable that can be set passing into it. But that allows you to change it in here because it's a reference back to the original, and you're changing the original no matter where it came from. I don't tend to use this a lot, but it is useful. There's another, well, functions are very useful for getting and modifying data, as well as simplifying a bunch of nodes that are performing one task into a single node, which is exactly what we did here. All of these nodes are just getting the start and end points for this line trace, so instead of having all of this on the event graph, we just did one node. You may ask, why can't we put all of this into it? Because perhaps we want to call this to line trace at one point for one specific thing, getting the name of an object, and perhaps we want it to be fired by a different event as well with a different possible thing. So that's another point of functions, is that they're designed to be very reusable. You can use them for multiple different things. And you'll notice on here that there is another input called target. This will always show up on your functions, and it says self in here, which means that this function is being run by this blueprint. Target is how you would run a function being held by a different blueprint. So, for example, if I opened up the level blueprint, which, just as a side note, it's not usually a good idea to write any code in the level blueprint, and we created a reference to this first person character, we could call line trace in here through this reference. Now this is very useful because this is used for getting one blueprint to talk to another, which I will have another video on later. And finally, a function should only be doing one thing. You shouldn't have a function that line traces and also heals the player. That wouldn't be a good function. It would have two purposes. A function should only do one thing. Now there is a special type of function that I will create here. We'll call this get gun offset length. And now we have this variable that's in our player by default called gun offset. And perhaps we need to get the length of this vector for some reason. So we can easily just do vector length. and then plug this in. An easy way to create an output is just to drag a pin onto it. And so if we compile that, that'll get us the vector length, and then put that in here. But perhaps we don't want execution pins for it, because this code doesn't have an execution pin. So the way to do this is to make a function pure. Pure functions are basically special types of functions that don't have execution pins. The reason you would want this type of function is only for getting data. You should never set anything within a pure function ever. And the reason is, every time this is run, it redoes the function. It recalculates it every time you get this data. So if we printed this data out twice, this function would be run twice. So we can just go in here and call this, it'll say function run every time this function is run, as well as then print the data. So we'll see what happens when we click. You'll notice that function run gets called twice, even though the value is the same. It gets called twice because it's being used twice, and this is why you don't want to set data within a pure function. You only want to set data through a function with execution. So that is something that I have never seen anyone show. I saw this on a project I was looking at made by someone else, and I had to go and figure out what it was. There's also a button for call in editor. So if we enable that, and then we go back to our guy here, if I can find the default category under this property or details tab, should be on here somewhere. The character thing is rather large. Well, apparently not. I will give this a group and call it lots of A's, so it'll show up at the top, hopefully. And did it? No. Well, I can show that on a custom blueprint later. That's not a character blueprint. Basically, this allows you to have a button in your details panel that you can click to call that function while in the editor. Again, mostly used for smart actors. And then finally, there are macros. So we can just create a new macro here. Dummy macro. If I can type. You'll notice that there is not even an execution pin on here. So if we go to create a new input and click this drop down box, there's this option on here to make this an execution pin. And then if we make another, there's also an option for a wildcard. So the execution pin is how you would add execution to a macro, and a wildcard is like any type of data. There are two special types of pins that only macros can have. Macros are another type of just collapsing your code that have a very particular use. In fact, oftentimes I never create a macro by clicking plus. I'll create a macro by selecting some code, like let's just select this code and collapse to macro, and we'll call this select on mounted display. And then we can go here, rename option 0 to false, and this one to true, because that's what they are plugged into the select. And then back in our event graph, we can copy and paste this macro here and no longer need that code. So we just basically collapse 2 nodes into one. That's a very small macro, but that demonstrates the essence of what a macro does. It's used for where you would copy and paste the exact same bits and pieces of code. Because a macro literally gets pasted back to everywhere that its node appears, such as here and here, on compile time. One downside of macros is that they cannot be accessed outside of the blueprint that they are defined in, which makes sense due to how they're copied and pasted in by the compiler, while a function can be accessed outside of it, as we demonstrated here. Those are the essential things, and now I said I would show you a function that can be called an editor. So I just made a new blank blueprint based on actor class, and we can make a function called print hi, and enable call an editor. And then if we were to drag this blueprint into the world, see under the default option there is a button for print hi, which calls that function. You can do this to a custom event as well. There is a thing for call an editor as well. And so this one will print a different piece of text, and you'll now notice that it also has a button. These are mostly used for making smart actors. Now, I mentioned earlier that some variables that you make can be made to be edited while in the editor, just like that. So we can call this variable, well, this is a, well, we can change it. We'll call this variable bounce. And then under the class settings, I'm just going to change this from an actor class as the base class to a static mesh actor, which I should have picked in the first place. And now we have, in the viewport, we just have this basic sphere. And, well, we don't need the print hi function. So, we'll just set up some basic things in here, and with this static mesh component, we're working in the construction script, making basically a simple smart actor. We can do set simulate physics, and then take our bounce variable and plug it into the simulate. Now, if we compile this, you'll notice that our thing doesn't have the ability to click on that and enable it. I mean, we could just set simulate physics, but it's not actually doing anything, because every time you're making simulating physics true, this function gets run, which is setting it to false, because bounce is currently false. So if we click on the little eyeball, you'll notice that it becomes open, and that instance editable becomes true. So if we compile then, you'll notice we have our default tab back with bounce set to true. And when we enable that, it enables simulate physics, and we can disable it to disable simulate physics. But in this blueprint, if we go to our event graph and off of begin play, we delay for example, 1 second, and then we set bounce to be true, and here bounce is false. Now if we go to play, definitely more than a second has passed, but physics hasn't been simulated. And the reason for this is we can just do a print string off of here. Is this running? Yes, it just run. You can see it says hello. So what's happening? Let's just put a print string on here to see when this is running. It doesn't. The construction script doesn't run in real time. So this is a thing to be wary of. When you make a variable instance editable and use it in the construction script to control another set of properties and then modify it during gameplay time, it won't rerun the construction script. It'll only rerun the construction script while in the editor. And you notice it now has physics because I enable it. It only runs that construction script while during real time while in the editor. So one practice that is actually relatively good for this is to collapse these to a function and call this update bounce. Gets called on the construction script. Then you can go over here and update the bounce. So with physics disabled, you can play, and there we saw it fell 1 second later. You can move this in front of the or not move it in front of the camera so it's easier to see. 1 second passes, then it falls. So that is a good thing to do if you want to have something that updates both in the construction script and in real game time, is to have that as its own function. And that's also how you would make a variable able to be edited in the editor. You can of course do this to any type of variable, whether it is an object reference, float, or rotator, any type of variable you can do that to. There are a couple of other options. Blueprint read only, that basically says there is no set node for this variable. You cannot set this with blueprint code. Expose on spawn is a relatively interesting one. So if we go to our level blueprint and we do spawn actor from class, and we set the class to be the new blueprint class that I never actually named, you'll notice that it has an extra input pin called bounce. This will set the variable of bounce when it is spawned. So if we disable that and compile and come back here, it's still creating our new blueprint class, but that bounce input pin is gone. Private is an interesting thing that I tend to use more with components, but you can use it with actors as well. This basically says this is a hidden variable. Actors that use this if it's a component, and actors that are derived from this actor, they're like subclasses of this actor, won't be able to see or interact with this variable. Exposed to cinematics is for use with Manatee or sequencer. It basically means this value can be keyframed. The category is what it shows up in. So if we named this into bounciness, you'll notice under variables there's a drop down for bounciness, but also if we were to select it in here, instead of being in default, it is now in the bounciness category, which is handled. Replication is for multiplayer, and then there are a number of other options that you don't always need. A config variable is this used for configurations? I am not sure what transient does. I never usually mess with this. Save game is this variable going to be saved to a file at any point? Like, for example, what level the player currently is on. You would want to save to a file so when they exit and come back on, they can be in the same place. And I am also not sure what advanced display does. These are not used very often. There is also the default value of bounce. This is what the value will be if you drop it into the world as soon as you drop it into the world. This is what the default value is. If it is not instance editable, this will be the value it is as soon as it begins playing. It'll be automatically set to whatever this value is. So that is the basics of structuring a Blueprint class, how you can collapse your code, a couple different things about setting up variables. I hope you learned something today.